Okay, today we will be talking about the multiple angle theorem, and for that we need to discuss about the double angle formula. So double angle sine 2 theta is 2 sine theta and times cos theta. Then we can talk about the tangent to theta, that is 2 tangent theta divided by 1 minus tangent square theta. If we talk about the cos to theta can be written in three different ways. So cos to theta is basically cos square theta minus sine square theta, and from this identity I can derive two more. So what we can do, one time we can replace cos square theta with a Pythagorean identity, and we can write it as 1 minus sine square theta minus sine square theta. With that we will get 1 minus 2 sine square theta. So cos to theta is also equal to 1 minus 2 sine square theta. Now let's replace sine square theta. So cos square theta minus in the parentheses 1 minus cos square theta. With that, we will get another identity, and that will be 2 cos square theta minus 1. So these are called the double angle identities or double angle theorem. Now, keeping that thing in mind, we have another something called power reducing formula, and power reducing formula, we can derive the half angle formula from the power reducing. So sine square theta is 1 minus cos 2 theta divided by 2. Cos square theta is the same, but the sign is changed. So it is 1 plus cos 2 theta divided by 2. So, and you know tangent is sine over cos. So tangent square theta will be nothing but 1 minus cos 2 theta divided by 1 plus cos 2 theta. Now, the another in this multiple angle theorem is the half angle formula, and half angle formula can be derived from these power reducing formula. For instance, if I take sine square theta, so if I take radical both sides, what you will get? You will get sine theta is equal to plus minus radical of 1 minus cos 2 theta over 2. Now let's replace theta in terms of a half angle. So let theta is equal to alpha over 2. So sine of alpha over 2, that means that is the half angle, right? Will be 1 minus cos 2 times alpha divided by 2 over 2. Now 2 and 2 will cancel out, and that will be your half angle theorem. So you don't have to memorize each and everything. You just have to understand how these are derived. So half angle formula, they are based on the power reducing formulas, and these formulas are very, very important even for the calculus perspective. You will use these often in calculus as well. So just the briefing of it: sine theta over 2, because we are talking about the half angle theorem. So cos theta by 2 is this, because it is derived from cos square theta, and then tangent theta over 2 will be, now here's the thing, we have a radical and radical, so it will be just 1 minus cos theta divided by 1 plus, no, not 1 plus cos square theta, because it will be squared, so it is just sine theta. So, or we can replace it as sine theta divided by 1 plus cos theta. It can be written in two different ways. Now let's try a few examples. So in the first example, they are asking us to solve cos 2 theta plus cos theta is equal to 0. Now, to do that, we can replace cos 2 theta with a double angle theorem that we just did. So cos 2 theta, it can be written three different ways. We are writing as 2 cos square theta minus 1, because I want everything in the cos format, because it will turn into a quadratic, and we know how to factor the quadratic. If you factor the quadratic, then it will become 2 cos theta minus 1 and cos theta plus 1. Now let's put each one of them equal to 0, so that we can get the angle. So this will give you cos theta is equal to 1/2 and cos theta is equal to -1. Now on the unit circle, cos theta will be 1/2 at pi thirds and at 5 pi thirds, because cos theta is positive in quadrant 1 and quadrant 4, and cos theta will be -1 at pi. Right? So having a good understanding of the unit circle, if it still struggling with the unit circle, there is a one a video on the playlist which says unit circle 1 to 3. Check it out and it will help you to construct the unit circle really quick. Now in the second problem, we have sine theta is equal to 3/5, and they have given us that the theta should be less than 5/2 but greater than 0. So with this information, they want us to calculate what is sine to theta, cos to theta, and tangent to theta. All of these can be figured out if I can create a triangle. And on that triangle, that means on the coordinate plane, we know sine theta is nothing but opposite over hypotenuse. So if we can get adjacent, then calculating all the double angles will be easier. So hypotenuse is always positive. So we have, this is the Pythagorean identity, Pythagorean triple, sorry. So Pythagorean triple, the basic Pythagorean triple, 3, 4, 5. So I know the adjacent is 4. So can I write cos? So cos will be 4 over 5 and tangent will be 3 over 4. And because the restriction says it should be between 5/2 and 0, we are talking about quadrant 1. So we have all the information about SOHCAHTOA, sine, cosine, and tangent. Now let's start writing down the double angle theorems. So sine to theta is 2 sine theta cos theta. We just figured out that sine theta is 3/5 and cos theta is 4/5. Multiply the fractions and you will get 24 over 25 as sine to theta. Let's do the same drill again for cos to theta and tangent to theta. I'm taking cos square theta minus sine square theta. For cos to theta, you can take 1 minus 2 sine square theta or 2 cos square theta minus 1 as well. In either of the scenarios, the answer will be the same. The same thing with the tangent to theta. It is 2 tangent theta divided by 1 minus tangent square theta. So tangent theta is 3/4. Be careful with subtracting with the fractions. With the fractions, when you subtract or add with the unlike denominators, you need to make a common denominator. So these are your lovely happy chappy answers. Let's take one more example in this line. Now they're asking us to rewrite cos 3x in terms of cos x. So we have done the sum and difference formulas for cos and sine. Let's apply that. So we can write 3x as 2x plus x. That is nothing but cos a plus b. As I told you earlier, cos tries to remain a little bit separated from sine. So cos a, cos b, minus, because if we are talking about the adding, it will be minus sine a, sine b. Now, cos 2x and sine 2x, these are my double angle theorem. So let's replace these double angle theorem. So this time I would like to write 2 cos squared x minus 1 because I want to keep everything in the terms of cos. And then sine 2x can be written as 2 sine x cos x. If we do distribution, we are getting this equation. But again, in this equation, we still have sine squared x. So let's replace sine squared x. Sine squared x, it's a power reducing, right? So we can use the power reducing formula, or the other way is I can use a Pythagorean theorem. So in this case, we are using Pythagorean theorem. So which is sine squared x plus cos squared x is equal to 1. So it is, if you use power reducing, then also it will work. Then let's clean this up because everything is in terms of cos only. Now we have a cos x. I can multiply a -2 at the same time. So let me rewrite it again. So it will be -2 cos x plus 2 cos cubed x. And let's combine 2 cos cubed x with 2 cos cubed x. That will be your final answer. Let's take one more example. Now we have tangent 4x, and they want you to rewrite in terms of first powers of the cosines of multiple angles. So let's tangent to the power of 4x. Can I write tangent 4x as tangent squared x and everything squared? Now, with the tangent squared x, that can be rewritten as tangent squared x is equal to 1 minus cos x cos 2 theta divided by 1 plus cos 2 theta, the power reducing one, right? So let's replace it. So instead of tangent squared x, we can write 1 minus cos 2 theta divided by 1 plus cos 2 theta and everything squared. Let's square it by using a minus b whole squared or a plus b whole squared property, binomial properties, right? Let me replace everything with theta. Instead of x, I started to write theta. Okay, so this will be 1 plus 2 cos 2 theta plus cos squared 2 theta. After this, we can clean this up again, cos squared 2 theta. Now here's the thing, cos squared theta is nothing but 1 plus cos 2 theta over 2. But in this case, theta is nothing but 2 theta. So instead of writing 1 plus cos 2 theta, it can be written as 1 plus cos 4 theta divided by 2. And we will do the same thing in the denominator as well. 1 minus 2 cos 2 theta plus 1 plus cos 4 theta divided by 2. Let's make a common fraction and clean this mess up. So it will be 2 minus 4 cos 2 theta plus 1 is cos 2 theta, not cos squared. 1 plus cos 4 theta divided by 2 plus 4 cos 2 theta plus 1 plus cos 4 theta. Right? We can combine the like terms, and we can leave the answer as cos 4 theta minus 4 cos 2 theta plus 3 divided by cos 4 theta plus 4 cos 2 theta plus 3. That will be your final answer. Let's take one more example. Find the exact value of cos 105 degrees. Now here's the thing. You can use some formula and you can write 105 degrees as a plus b cos a plus b. Or the other way is to use the half angle theorem. So I will show you both ways. So cos 105 degrees can be written as cos of 60 degrees plus 45 degrees. And then you can go ahead and use cos a plus b. But because in this particular video, we are talking about the multiple angle theorems, so let's use the half angle theorem. So I know 105 is nothing but half of 210 degrees. So theta over 2, I know cos theta over 2 is plus minus radical of 1 plus cos theta divided by 2. In this case, theta over 2 is nothing but 210 over 2 because theta is 210 and half of 210 is 105. we are just taking the negative value because it says 210. 210 will lie in the second, half of 210 will lie in the second quadrant. So that is why instead of taking a positive value, we are taking the negative value. And what is cos 210 on the unit circle? That is negative radical 3 over 2. So let's proceed ahead, make the common denominator. And that, and now 2 is outside the radical because 2 from the numerator will go down, which has already a denominator of 2, which will become radical of 4. And radical of 4 is nothing but 2. So the same problem can be solved in different ways. Let's take one more example. Now they're asking us to find all solutions of cos squared x is equal to sine squared x over 2, that's the half angle, right? X over 2 is the half angle. In the interval of 0, 2 pi. 0 is included, 2 pi is not. Now cos squared x okay, there is some glitch. Let me rewrite it again. Cos squared x is equal to sine of x over 2 squared, because sine squared of x over 2 is nothing but sine x over 2 everything squared. And that is my half angle theorem. So half angle theorem is plus minus radical of 1 minus cos x over 2 everything squared, and squared will take the radical off. If I do cross multiplication, we are getting 2 cos squared x is equal to 1 minus cos x. Let's take everything on the left hand side and make it a quadratic. Now if I factor it out, 2 cos x minus 1 and cos x plus 1 is equal to 0. And let's put them one by one equal to 0. That will give you cos x is equal to 1/2, and on the unit circle, x will be pi thirds, and 5 pi thirds. Cos x is equal to -1 will be at pi. So this is the gist of multiple angle. I will see you in the next video.